Peter had twice as much money as Amber at first. Peter spends 1/3 of his money and Amber spends 2/3 of her money. In the end, Peter had $75 more than Amber. How much money did Peter have at first? So right now what we are given is in the beginning, they have given us a proportion between Peter and Amber twice, and they give us the change for each person in terms of fractions, okay, which is the 1/3 and Amber spends 2/3. Now, do take note that these two denominators do not represent the same value because both denominators belong to two different persons. Okay, this 3 belongs to Peter, whereas this 3 belongs to Amber. And we know for sure that both denominators are not the same value because at the beginning, Peter had twice of what Amber had. Okay, so how are we going to solve this? So twice, 1/3 and 2/3, notice that all this proportion, we can actually rewrite them as ratios. So if we rewrite them as ratios, we can use the before change after method to solve, and we can then use BCA ratio for the change involving the fractions here. Okay, so let's see how we're going to do that. So let's start with the before ratio, Peter to Amber. This will be 2:1 because twice. Now then the spending comes in. So the spending, we use arrows to represent the spending. Spending is a change. So Peter minus 1/3. Now be careful, there are some situations whereby here it's a plus. Okay, so depending on what action is taken here. In this case, this action is spending, so the money decreases. So with this minus 1/3, I can rewrite this as a mini BCA ratio at the bottom. All right, so this BCA represents before, change, after for Peter alone. Do take note of that. Now, when you write the ratio for this, do not ring this number to put it right here. Okay, do not do that because anyway, later you will be identifying your common base. So what you should do is just make use of this 1/3, okay, to translate it into this BCA ratio. So when I say Peter minus 1/3, think of it simply as he has 3 units at first. The denominator 3 belongs to him at first. So that's the before. Now, and out of his 3 units, he is going to spend away 1 unit. So the change is minus 1 U. After that, what is left? After that, he is left with 2 units. Okay, so this is what I mean by the BCA ratio. Now we're going to do the same for Amber. So Amber, let's draw another arrow to represent her change. So Amber, she spends 2/3. Same thing, you can write this down as a BCA ratio for this. So again, when we look at Amber's BCA, do not use this Amber to put it here. Don't do that at this point. All right, you should be making good use of this fraction, 2 and 3, to translate them into the bottom ratio here. Okay, so again, if I say Amber spends 2/3 of her money, that means these 3 units belongs to her money at first. At first means the before. So this is 3 units. Okay, oops, too fast. All right, and out of 3 units, she is going to spend away 2 units. So minus 2U, that's the change. So your change must either be a minus or plus. Okay, if this is a plus, then of course there's an increase for the change then. Now what happens after that? So now she's left with what? She's left with only 1 unit because 3 minus 2. All right, so this is how you write down the BCA ratio. So once this is done, let's read on. In the end, Peter had $75 more than Amber. This more than Amber is a difference between both of them. So whenever a difference is presented like that, usually we just sketch a simple model based on that information. So Peter, 75 more than Amber. So there you go. You have a before, the change, and the after. But within the change, you have more detailed BCA ratio under this change. Okay, so once your data is recorded, see step 1, you record down all the information given from the question first. Okay, the next thing is step 2, you need to identify your common base. Now you see 3 sets of ratio. When we have 3 sets of ratio, typically we should expect up to 2 pairs of common base. Okay, so let's identify what are our 2 pairs of common base. So the first pair, usually I'll look at these 2 first. Okay, so notice this is Peter's ratio. And I also have Peter here at the start here. Remember, this is before. Okay, so since this is before, then it must mean that Peter's before will be my first pair of common base. Now, what's the second pair of common base? So second pair, if you look at this is Amber's ratio this time. Okay, so how do you know which one to compare with? So Amber, I will look at Amber here. No point looking at these two, okay? No point comparing between these two because these two confirm no common base one because these two belongs to two different people anyway. Okay, so look at the names first. So Amber and Amber. So I have Amber and Amber, most likely that will be my common base. Then the next thing is ask yourself, is it Amber before or Amber after? So like I said, this ratio belongs to the before part, right? Before means at the beginning. So if it's before means I have before, Amber before is your common base also. Okay, so let's proceed to make our bases common. So let's start with Peter first. So it doesn't matter who you want to begin with. It's really up to you. Okay, so let's say I start with Peter first. So Peter, before here shows 3. Before here shows 2. So 2 and 3 must be the same units, right? Because it's representing the same Peter units at first. So 3 and 2 common multiply is 6. So change this to 6. This also change to 6. That is your first pair of common base. Next one is Amber. So let's look at Amber. Amber before now shows 3, now becomes 3. Amber before also 3 here. Okay, so luckily just nice, already common. So 3 and 3. So do underline your two different pairs of common base. Okay, try to do that. To make it a habit that, okay, I am done with my common base and I'm ready to move on to solve the question. Now, once your common base settled already, okay, you can now start working with the usable value. The usable value will be this $75. That's the only value given to me, right? And this $75 indicates a difference between both of them in the end. In the end means you must look at the after ratio, after units. So if you look at after for Peter, after for Peter is 4 units, whereas for Amber is 1 U. So we're going to indicate them on the model. Peter, this whole stretch is 4 units, whereas Amber, this stretch will be 1 unit. Okay, so I'm actually extracting the units from the after sections from each of their respective ratios and put it down onto the model. So once this is done, you realize that, oh, I can easily find $75 is how many units now? Because $75 will be 3 units, 4U minus 1U. All right, so this portion, 3 units. So 3 units is $75. Hence, always look out for 1 unit after that. Okay, so 1 unit is $25. Once this is done, look back at the final question. Okay, always, last step, always read back the final question. How much did Peter have at first? You want Peter at first, so look at Peter at first, right at the beginning here. Peter at first has 6 units. Do not use back 2. You already do common base. Always use the newest units because that newest units is the reliable one that unites all 3 ratios together. All right, so 6 units is what Peter have at the beginning. So you are going to look for 6 units, which is 25 times 6. And that's $150 for Peter at first.